All right, what up, guys? Let's do this test three scatterplots and linear regression review. Here we go. So, a researcher wishes to determine whether the rate of water flow in liters per second over an experimental soil bed can be used to predict the amount of soil washed away in kilograms. In the study, the explanatory variable is the way I remember this is I'm thinking about the explanatory has the letter x in it, so I'm thinking about it as an x variable. So I'm thinking about this on the horizontal axis. That's how I remember what's going on. The other one, the y, by the way, we call the response variable in statistics. I know it's annoying because you're used to independent and dependent. However, you don't want to use those words for stats as much because they mean kind of something different later when we do probability. So we kind of split the definitions to be less confusing elsewhere. Anyway, so in this question, we're asking what is the x variable here? So we're testing to see whether the rate of water flow can be used to predict the soil amount. So the water flow is going to be our x variable here. So the rate of water flow, right? And liters per second, it kind of sounds right, but it's actually just the units of it. Um, and yeah, I think we're good. I'm done explaining. All right, going on to number two. All right, number two. Which of the statements contains an error? Which statement could be correct? All of these contain an error. Which could be correct? Oof. All right. So R by definition, by the way, is always no matter what in between -1 and +1. You might see this written in the absolute value format where you just see it as less than or equal to 1 this way. So all these are supposed to be ones. I apologize. My ones don't look right. So oh, I'm not able to see what I'm writing. Okay, now we're good. So anyways, we're doing this question here and we're trying to figure out the statement about R, so we have to have that. The other thing about R is the correlation coefficient. It tells us if something already appears to be like a straight line, how close is it to a straight line really, with positive values indicating a positive slope, negative values indicating a negative slope. And it can only be used between quantitative, those numerical style of problems, and they both have to be numerical. Anyways, this first statement, the correlation of 0.54 between a position and his weight. So position is a categorical variable because you don't have like a number on your position. You're either a corner or a left tackle or a quarterback or whatever. So this is definitely not true. We found a correlation of negative 0.63 there, which is fine, between gender and political party. So these are both categorical variables. Gender is a category, political party is a category, so definitely not okay here. Correlation between distance traveled by hiker and time spent hiking. So finally, we have one that has two actual correct statements here, some quantitative variable, but the problem is it adds in these units. R is unitless, so we can't have that. R is unitless, so careful about that. We found a high correlation. R is 1.12, doesn't make sense. It has to be less than 1, and that leaves E as our only considerable answer there, or possibly correct answer. We got soil moisture, that's quantitative. Per acre yield, that's quantitative. Between 0 and 1, we're done. Number three, consider the following scatter plot of the amount of carbon monoxide and nitrogen oxide in the grams per mile driven in the exhaust of cars. Least squares regression line has been drawn in the plot. Based on the scatter plot, least squares regression line would predict that a car that emits 10 grams of carbon dioxide per mile would emit approximately how many grams of NOx per driven mile. So the idea is where is this 10 on the line? Where does it appear to line up with the other side? So we're kind of going left here, and maybe if I was being a little bit more careful, I could grab a ruler or something, but I'm not being more careful right now, being a little bit lazy, and that's okay. So it looks to be about a little bit over 1. So the only one that has a little bit over 1 appears to be letter D here. So we'll put a letter D in our box right there. I'm going to pause really quick, take a drink. All right, so also changed my camera and we're on question 4 in my little pause there. Anyways, here we go. We got consider the following scatter plot of amounts of carbon monoxide and nitrogen oxide in grams, blah, blah, blah. It's the same exact thing as the last question, right? In the scatter plot, the point indicated by the open circle, that's this one over here. What's going on with it? It looks like we're asking about residuals. So the residual is this length from here to here. Every single time you have a residual value, it is always going to be the actual minus predicted. So residual, as a reminder, is always going to be the actual minus the predicted. So because it's the actual minus predicted, in general, if you are below the line, let's think about this really quick. I'm going to write this right. So what this means, little implication line there, this means if you are below, that means the actual one is going to be below, is going to have a negative, below is a negative residual. And if you are above, instead, above is going to mean that you have a positive residual. This is going to be always true for these lines, regardless whether it's going up, going down, whatever. If you are below that line, negative residual. If you're above the line, you get a positive residual. And that's really because you're doing an actual number minus a predicted number, and the smaller minus the bigger is always going to give you a negative. So we're looking for a negative value for this particular residual because we're below the line. Done. Easy peasy. Letter A is what we are looking for. Let's read the next one. The computer output shown below gives the least squares regression line for calories and protein in grams in 1 cup of 11 variety of dried beans. Which of the following statements? So I think I'm just going to go through this one more time in case anyone missed it in class, what all these different things are. So basically, over here, just as the word predictor, these are the various different things we could have, but this is going to line up with our, in a y equals mx plus b situation. This right here is going to line up with our letter b, the constant, and this right over here is going to line up with our letter m, the slope. And specifically relating to calories being the x part of the slope. So this is the x part, I would say. I can't know if you can even read that handwriting. That starts with x part of the slope. So this is like the x value, the y value, and don't forget these are always a hat, right? You're predicting. Other parts in this, the coefficient. This is the actual value, or I don't know, the actual b value, the actual m value. It's not the actual value for the situation. You don't know what the actual value is for the situation, but it is the calculated value. I should have said instead of actual value. Maybe I should have said calculated here. Calculated. All right. Anyways, this stands for standard error of the coefficient. You can think of this as to about how off is the b value, how far off is the m value. We will not use the standard error of the coefficient at this point in time. We will use it much later in the year, but again, that stands for standard error of the coefficient. It's effectively the standard deviation of the b value or the m value. Not important for right now. T stands for test statistic. Test statistic specifically for the t distribution of the student's t distribution. Again, not something that we're going to be too worried about at the moment, but it will be important later, along with the p-value, also not important at the moment, but will be important later. S, this right here is the standard deviation of the residuals. This is our standard deviation of residuals. And the standard deviation of residuals, what that means is how far off your prediction line is in general. How far off is your prediction line usually? Whew. All right. This one is our r squared. Remember, the r squared is our coefficient of determination. Our coefficient of determination tells us what percent of the variability in the scatter plot can be described by a straight line situation or a distribution. How much of our variability in our distribution can be described by the straight line prediction. Either way, which of the following statements is a correct interpretation of the slope? So the slope is for each 1 unit, what's going to be happening for each 1 unit increase in calories is going to be how much is a change in protein here. So that's what we're looking at. So a 1 units. Let's see, a 1 unit increase in calorie content. We got predicted protein. Boom. That's what we were looking for. Letter B. I'm taking another break. All right, so we got this below a scatter plot with the least squares regression line for calories and proteins and 1 cup of 11 varieties of dried beans. Computer output, it's the same exact stuff as that previous question, right? The same exact numbers. Lima beans have 621 calories and 37 grams of protein. What is the residual? So we're going to need two things here. We're first going to need to calculate what is the actual predicted. That's funny. What is the predicted value of protein for a 621 calorie situation. So our predicted amount, let's go ahead and write up our regression equation. We have our y hat is equal to our slope. Our slope is the number in front of calories there. So we got 0.06297x plus 2.08. And we're going to be plugging in a 621 into here. So our y hat is going to be equal to 0.06297 multiplied by our 621 plus 2.08. Definitely going to need a calculator for that. I am good at math, but not that good at math. 0.06297 parentheses 621 end parentheses plus 2.08. This appears to be 41.184. And we'll round to 4. Going to 4 decimal places always in this class. Here though, don't like write down the answer right away. It looks like, oh, there's the answer, we're done. No, residual is the actual minus predicted. So we have actual minus predicted. And because we have actual minus predicted, our actual is going to be 37 minus that 41.1844. So we're going to be doing 37 minus the second answer there. We're going to get negative 4.1843. 7, I guess, 4. All right, either way, that is our letter B. B. Here we go. Going number 7. In a statistics course, a linear regression equation was computed to predict the final exam score from the score on the first test. The prediction equation was y hat is equal to 10 plus 0.9x, where y is the final exam score and the x is the score on the first test. Bill scored a 90 on the first test and a 93 on the final exam. What is the value of his residual? So his actual score on the exam was a 93, but his predicted score was y hat is equal to 10 plus 0.9 multiplied by 90. Don't need a calculator for this one. We're going to get 91 there. So our actual minus predicted was 93 minus 91. That is positive 2 this time. There we go. All done with that question. Let's move on to our last page of multiple choice questions. I'm sorry that whole thing was sideways the whole time. I hope you didn't have to like turn your phone or anything, but all right. We just talked about this one earlier, what S was. S is the standard deviation of the residuals. It's how far off you are usually, and that's going to be letter E here at the bottom. When using this regression equation to predict the protein content from the calories, we will typically be off by that much. Yeah, we're done. That's our letter E there. That was a fast, easy one. If you want to read through the rest of them, we can. We don't need to. By the way, if you want to like think about like how other answers might be, this is a definition for r squared, which would have been 43%, by the way. If you want to know the variability in protein content, if that was a 43%, that would have been perfect for an r squared definition. The typical distance between these two, so the observed protein, that's not what we're doing here. We're doing the predicted and observed. So we're not going to worry about these. I'm done talking. We're going to go to number 9. Here we go. All right. You are examining the relationship between X is the height of the red oak trees and Y is the number of acorns produced in a 5-year period. Calculate this correlation coefficient. You switch the variables, which would be true. So when you switch variables, the correlation coefficient will stay exactly the same. If it was a positive slope before, it'd be a positive slope after. If it was a negative slope before, it'd be a negative slope after. There aren't any units in a correlation, so that's going to be the same. However, the regression line is going to change because the slope's going to change. In fact, you're going to be making the reciprocal of the slope instantaneously. So because you're going to be making that reciprocal of the slope, definitely going to be a different thing. The correlation coefficient would not change. The regression line would. That is letter C. Continuing on, we got fisheries report which one, blah, 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 with this natural logarithm thing. So this question actually is one of the most difficult on the test for many students, only because you do have to use some of your Algebra 2 knowledge. If you've forgotten that Algebra 2 knowledge, let's do it. So which of the following is the closest to the predicted weight of the gracile lizardfish was 12 centimeters long? So 12 centimeters long, 12 is going to go in for the L. So we got the ln of W is equal to negative 5.36 plus 3.216 multiplied by the natural log of 12. If you want to know why ln and natural log are in the wrong order, it's because in Latin it's logarithmus naturalis. And that's why apparently we have to use the Latin. Anyways, we're typing this in as it appears, negative 5.36 plus 3.216 multiplied by the natural log. Natural log is this button right here. Boom. And put in a 12 right here. And that's going to give us 2.6315. That is our natural logarithm. And in order to solve a question like this, we're going to need to use our e-fact. Our e-fact here is if I have the ln of x is equal to y, no matter what, e to the y is equal to x. This is a true statement, often called the log loop. I like to think about it as the ln becomes an e, and then the x and the y switch spots. So again, the ln becomes an e, the x and the y switch spots. So in this case, the ln becomes an e, the x and the y switch spots. Our predicted prediction, whatever, our predicted W. So our predicted W here is going to be e to the 2.63. E to the 2.63. We'll need our calculator. It's it's about 3 to the third, so we're expecting something a little bit bigger than probably 13 is what it's going to end up being, is what I'm saying. Either way, let's actually do the work for it. So we have to hit second ln now. So we hit the second ln button. You didn't see my finger. The E is right there. And we are doing 2.6315, or just using the answer. I'm using the answer, and it turns out it's 13.89. And that is just like we thought, letter C. Boom, boom, boom. Let's move on to that last page, the free response question. Here we go. So we got our free response question. Following the Scatterplot describes the relationship between the age in years and the price in thousands of dollars for 12 used Ford Explorers. Describe what the Scatterplot reveals about the relationship in years and the price in thousands of dollars for these 12 used Ford Explorers. So as a reminder of what all the things you want to talk about when you're doing these questions is any Scatterplot is going to need the direction, form, strength, and outlier discussion. So if I was to answer this one myself, I would say there is a clear, moderate, negative. So let's talk about it really quick, what I've said so far. Clear, moderate, these are both talking about the strength. The negative part talks about the direction. So I still need form and outliers. A clear, moderate. Man, I can't even speak really quick. I'm going to take a break. Okay, that was like a 2-second break. We're good though. All right, clear, moderate, negative, linear. Either linear or non-linear, by the way, whenever you're doing form. So clear, moderate, negative, linear association, or relationship. Maybe I should say relationship. Between, I'm doing B/N for between, between the age and price of Ford Explorers. In my opinion, there are no obvious outliers. However, you could say that 3/16 are possible. So you could say there are no obvious outliers, but 3, 16,500, because that's what it is in thousands of dollars, appears is a possible outlier. So you don't have to mention possible outliers, but it makes you sound better. in my opinion. So you should add that in when needed. All right, there we go. Next thing up below is a computer printout for a least squares regression analysis. Write the equation of the least squares regression line. So just like we talked about before, we can do this pretty nice and easy. So we're going to have y hat is equal to negative 0.9496x plus 21.405. And you could add in a sentence there on the actual AP test about how where y hat is the predicted price of the Ford Explorer after X years, blah, 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 could be good. You don't need to. And when you're interpreting the slope, you're going to say for each, I'm not going to write this all the way down. I think you can hear me while I say it, or you can use the subtitles on YouTube if I talk slow enough. If you want to interpret the slope, what you're looking for is for each 1 unit increase, there is a predicted change. That's the type of language you're going to want to use. In this case, we're going to say for each year after purchase, there is it's in thousands of dollars, so 0.9 is in the hundreds, is a $949 decrease in predicted value of car. Or you could say you could move this word predicted, you could move this maybe a little bit better right here instead of after. There, for each year after purchase, there is a predicted $949 decrease in the value of the car. That could be a better way of wording it, but it's going to be very, very close. For the y-intercept, I'm totally out of room for even writing this down, but the y-intercept, what's that going to mean? The y-intercept is going to mean, in this case, if the Ford Explorer had just been purchased, the price. Maybe I should write that down anyways. All right, so go over here. If Ford Explorer had just been purchased, the y-intercept would be its price. Would be its predicted price. Why did I even write that down? My handwriting is so terrible that no one's going to be able to read it anyways. I apologize to everyone who had to experience that. All right, use the least squares regression line to predict the price of a 5-year-old Ford Explorer and show your work. All right, we can do that. We're going to use our least squares regression line right here that we already had. We're going to plug in 5 there. So that's going to be nice and easy. So this is for letter E. So y hat is going to be negative 0.9496 multiplied by 5 plus 21.405 using our calculator. Here we go. So we have should have been negative 0.9496 5 plus 21.405, and we got 16.65. And remember, this is in thousands of dollars, so we probably want to write that as 16,657 is the predicted price of a Ford Explorer 5 years after you have purchased it. Okay. Comment on the use of a least squares regression line to predict the price of 25-year-old Ford Explorer. F, not appropriate. Not appropriate. Appropriate, since using the least squares I'm going to slow down my writing so you can actually read it. Regression line is only appropriate when within the domain of original values. In this case, any value outside of 3 to 9 years would result in extrapolation. Can't even read what I wrote there, so I went off the screen. So what did I write? Not appropriate since using the least squares regression line is only appropriate when within the domain of original values. In this case, any value outside of 3 to 9 years would result in extrapolation. Whew. All right. Last but not least, identify and interpret the coefficient of determination. So our coefficient of determination, this guy right here for letter G, this is r squared, and in this case, it is 0.474. You could have also written the percentage version, and what this means is that 47.4% of the variation between age and price of the Ford Explorers, varies between age and price of Ford Explorers can be explained by the least squares regression line. By the least squares regression line. LSRL, least squares regression line. I just termed it. I'm not writing the whole thing out. Love you guys. Peace out. Have a great rest of your day.